All right, we're on the 1.8 study guide. We're talking about parallel lines and proofs, whereas the last section we were talking about intersecting lines and proofs. So this time the lines do not touch, and this opens up a whole new series of relationships between certain angles. So let's go ahead and get some definitions first, and then we will look at some examples. So skew lines. In 10 words or less, please define each pair of lines. So a possible response could be lines in different planes. But go ahead and Google it and see like what pops up for skew lines. And also if you Google it, you can find an image. I'm going to go down here to insert a media. And I just got this little image here so you could kind of compare. But basically, picture these parallel lines. That's the next definition we're doing. Look at these intersecting lines that touch at one point. Look at perpendicular lines. And then here's our example of skewed lines. They're on different planes and do not intersect. So we can add that piece to the definition as well. All right, let's look at parallel lines now. And they're right there in that image as well. All right, for parallel lines, we could say coplanar lines that never intersect. So just like the skewed lines do not intersect, these lines don't intersect either, but these are on the same plane. So skewed lines are lines in different planes that do not intersect, and parallel lines are coplanar lines that never intersect. All right, fill in this Venn diagram. So skewed lines lie in different planes. Parallel lines lie on the same plane. And both never intersect. Okay. All right, let's look at the next section here. Use notation and marks to summarize the line relationship. Line AB is parallel to CD. So here I want to go see if we have this little symbol in our CAMI. There they are. There's our parallel lines. Okay, cool. So we can say AB Actually, I think I'm going to hand draw this just to be safe, because I want all the little pieces of notation that you're supposed to have. So line AB needs to have the line on top with the arrows is parallel to line CD. Okay, so notice when I'm writing this, how we put the notation for each section. So line AB with the two arrows is parallel to line CD with the two arrows, okay? And how do we draw that picture? We're showing these two lines, AB and CD, and notice the little symbols right here. These symbols stand for parallel. Almost looks like two little matching arrows, and those mean parallel. Those are the notation that tell us two lines are parallel. All right, parallel rule. Let's show this rule. For any given point P, there is one line that goes through it that is parallel to line AB. So I'm going to go grab my line. All right, how'd you do? In 15 words or less, define transversal. So the transversal is that line that goes through the two parallel lines. So let's say, how might you describe this? You might have searched it and found that it is either a ray, a line segment, or a line that crosses a set of parallel lines. I don't know, something like that. Did you search it and find something like that? So for that as our definition, now look over at the image. And what would be your transversal? I'm going to go ahead and highlight here. Oh, it's not letting me highlight down the line. So let me go grab this. This one is our transversal, okay? This line going through the parallel lines is our transversal. So let's go ahead and label that. Point to that yellow line and call it transversal. So it's the line that's going through the parallel lines. And when it does that, it forms some angles, and these are the relationships we're going to be talking about today. All right, complete this chart to talk about these special types of angles, okay? So this is what we did today in notes in class. We talked about corresponding angles. These angles are not adjacent or side by side. These angles are on the same side of the transversal. They are on the same side of each parallel line, and we know that they are congruent. So let's go mark, label one pair of corresponding angles 1 and 2. So this and this are corresponding angles. This little angle here and this little angle here. Or you could have marked this and this, because these are corresponding angles, this little angle here and this little angle here. Notice they are on the same side of the transversal, on the same side, top and top of the parallel line, and we can say that those are congruent. You could have also said that this bottom one and this bottom one, 1 and 2, are corresponding angles that are equal. And you could have also said that this one and this one are equal, 1 and 2, those two bottom side ones. Anyways, whichever ones you chose, maybe you went back to these original ones, those can be your sets of corresponding angles. Okay, and what we say is that corresponding angles are equal, so 1 equals 2. Congruent means equal in measure. Okay, let's go look at alternate interior angles. We're going to label these 1 and 2. Alternate interior angles are inside of the two parallel lines. They are not adjacent. They are on opposite sides of the transversal. And we say that they're congruent. So we say 1 equals 2. Okay, consecutive interior angles. I actually called these by their other name during class. These are called same side interior angles. So I want you to have both names. And same side interior angles are not adjacent. They are on the same side of the transversal. They are inside the parallel lines. And they are not equal. They are supplementary. So this time, let's go draw them where same side interior angles or consecutive interiors are right here on the same side and inside the parallel lines. So then what other ones would be considered same side interiors? These guys over here. could also be considered same side interiors. How are we going to solve those? We're going to say that angle 1 plus angle 2 equals 180 by definition of supplementary. Notice that one looks obtuse and one looks acute. They look like they add up to 180 if you look at them in the picture. All right. Line T intersects parallel lines 1 and 2. So here's our transversal. Here's line 1 and 2. We're now going to go through and say what angles are corresponding, what angles are alternate interiors, and what angles are consecutive. So sorry that this little line over here got cut off. So let's draw that line in. Okay, so I'm just going to handwrite these corresponding. Let's go corresponding first. All right, looking at the picture, corresponding means on the same side as the transversal, but in the same spot. So for example, 1 and 5. Pause the video here and try and find all the other pairs. And let's see how you did. We also could have said 2 and 6. We also could have said 4 and 8. We also could have said 3 and 7. How'd you do? Now let's go talk about alternate interior angles. These are going to be on different sides of the transversal inside of the parallel lines. So for example, angle 4 and 6. Can you see one other pairs of alternate interior angles? Yep, you got it. 3 and 5. Finally, consecutive interior, which I call same side interior. This is the name I see more often. Apex is using this other name. So for the same side interiors, we're looking at, for example, 4 and 5, and we're looking at 3 and 6. All right, now real quick, just to remind you of the relationship between all of those. Corresponding angles are equal. Alternate interior angles are equal. Same side interiors are supplementary. They add up to 180 degrees. So keep those ones separated. All right, let's go practice some examples now, given these. All right, so looking at this first one, do you see how they are both on the same side of the transversal and they are both interior? So when we recognize what it is, you're going to type it out. You're going to say that these are same side interior angles and that they are supplementary. Okay, so the angle pair is x plus the 121. Sorry, I wrote that on the wrong line. We already wrote what it was. So the measure of angle x is equal to 180 minus 121. So grab your calculators. And we get 59 degrees. Now for the next one, these angle pairs are corresponding. And we know that corresponding angles are equal. So we see that measure of angle x is just equal to 110 degrees. Finally, we see alternate interior. Angle. And we know that they are equal. And so we see that x is just equal to 60 degrees here. Now, what if they asked me for y? I can tell that y is a corresponding angle to the 60 degrees. So I could just say that y equals 60 based on corresponding angles, or I could say that x equals 60 by alternate interiors, and then x equals y by vertical angles. What if they gave you a 40 over here? Actually, let's make it 60 because of the picture. And they asked you for this angle? Well, you could say 60 is equal to 60 by corresponding, and then y is equal to 60 by verticals. Or you could say 60 is equal to x by vertical angles, and that x is equal to y by corresponding. So I want you to be aware that there's ways to get to other angles if it doesn't fall right into the category of what we're looking for, by doing a couple jumps, like here to here to here, here to here to here, etc. You can jump around and find the answers. Okay, finally, we're going to draw a transversal that intersects the two lines. And by the way, this is how to tell if two lines are parallel. We draw a transversal that intersects the two lines and ask ourselves, are there any two corresponding angles that are congruent? Are any two alternate interior angles congruent? Are any two consecutive interior angles congruent? I'm sorry, supplementary. And remember that the word that I'm using for this is same side interior angles. If the answers to any of these questions are true, or yes, then the two lines are parallel. So this is leading us into, we are going to be looking at proofs to see if lines are parallel. And this is going to be the basis for those proofs. We're going to look for two corresponding angles that are congruent, or two alternate interior angles that are congruent, or two consecutive interiors that are supplementary. If we have that, we can therefore say that they're parallel. Sometimes in our proofs, we are given that things are parallel, and we use those to prove other things.